Solving equations by graphing. All right, so now we're going to look at how to solve y equals f of x and y equals g of x when they intersect. So basically when it says f of x equals g of x, how do we solve for that type of problem? All right, so to be successful, you need to be able to solve a linear equation by graphing, solve an absolute value equation by graphing, explain why the x-coordinate of the point where y equals f of x and y equals g of x intersect is a solution of f of x equals g of x. All right, so we are going to be looking at some equations, f of x equals g of x, and we're going to be looking for that x value, which will be considered the solution. All right, so the key idea here, when you're solving equations by graphing, to solve an equation, f of x equals g of x, first write the function to represent each side of the equation. All right, so you're going to have one equation, y equals f of x, that's the left side. Y equals g of x, that's the right side. So this is just in function notation. And again, this may be different. It may be h of x or m of x or whatever, but this is just an example of function notation. All right, step 2, we're going to graph the functions, and the x value of an intersection point of the graphs of the function is a solution of the equation f of x equals g of x. So when you see it set up like this, f of x equals g of x, first write your two equations, solve by graphing, and remember that the x value is your solution. All right, example 1, solving a linear equation by graphing. So here it says solve negative x plus 1 equals 2x minus 5 by graphing. Check your solution. All right, so let's look at first step. We need to write y equals negative x plus 1 and y equals 2x minus 5. So we can conclude that if we want to use the same notation as in the previous slide, we can say this is f of x, this is g of x. So we have an equation, f of x equals g of x, and we need to solve by graphing. So now we have two equations. Now we need to go to our calculator and set this up. All right, so let's go to y equals negative x plus 1. All right, and our second equation is going to be 2x minus 5. And we're going to hit graph. All right, so we can see that it has now graphed these two lines. So we can do second trace. Let's find the intersection point. So we're going to click on 5. All right, it says first curve. So we have to click somewhere to the left of this point. So I'm going to hit enter. Sometimes you have to move it a little bit, but all right, it says second curve. So that means I have to move somewhere to the right of it. So what it's doing, the calculator is wanting me to isolate this area. So if I put a point on one side and the other side, then it's going to say guess. I hit enter one more time, and it's going to give me the intersection point. So remember, the x value is the solution. So this says x equals 2 when y equals negative 1. So we're going to say x equals 2 is our solution. We found that by graphing. If we want to check the table, we can do second table. And we can come down here and see when x is 2, it has the same y value. So you can see that those do have the same y value. So that means it's going to intersect at that point. You also can take this value to check it. You also can take this and plug it in. So my original equation, negative x, let's take 2 and substitute it in for x plus 1. And that's going to equal 2 times x is 2. And then minus 5. All right, so if this is a solution, that means this should now be equal. This should be a true statement. So negative 2 plus 1 is negative 1. Does that equal 4 minus 5? 4 minus 5 is negative 1. So negative 1 equals negative 1. So you can see that that proves that has checked it, and it proves that this is a true statement. So x equals 2 is a solution to this equation. All right, I want you to try this one on your own. Remember, set up your equation. This will be your first equation. After the equal sign will be your second equation. Graph those, find the intersection point, and the x value will be your solution. Make sure you check it when you're done. All right, hopefully you took time to do this and you got a solution of x equals -2. All right, so y equals 1/2 x minus 3. The other equation, y equals 2x. Plug that into your calculator and graph it. After that, you can do second, trace. Number 5 is intersection. And then again, you have to go somewhere to the left of that point. Hit enter. Go somewhere to the right of that point. Hit enter. Those two little things show that it's isolating around that area. And then it's going to find the intersection. X equals -2 and y equals -4. Remember, x is your solution, so x equals -2. If you want to check that using your table, go to second graph. That's your table right here. And you may have to scroll up, but right here is x is -2. X is -2 shows that both y values will be -4 at that point. So when you plug it in, you also see that -4 equals -4. So it shows that x equals -2 is your solution. So when it says solve by graphing, that's all you have to do. Very simple. You just have to know the steps to get the correct answer. You also can think of this in the same way as solving a system of equations. If you look at the study tip here, it says you can think of this as solving a system of equations where y equals f of x, y equals g of x, by graphing. So when we solved a system of equations by graphing, this is exactly what we did. We found the intersection point, and that was the solution of the system. All right, here's a couple more I want you to do on your own. So again, pause the video, see if you can answer these, and then we will talk about them together. All right, the top question says, explain why the x-coordinates of the points where the graphs of the equations y equals f of x and y equals g of x intersect are the solutions of the equation f of x equals g of x. Okay, so explain why the x-coordinate. All right, so let's pick a random point. So we know that the point of intersection is going to be the point that's important. So let's say let graphs f and g intersect at point AB. So instead of using x and y, let's just use AB for this scenario. All right, so if we let graphs f and g intersect at this point AB, because f of A, this is like f of x, right? This is in the same spot as my x. F of A is going to equal my y value, which in this case is B. This is x, this is y. We're just using A and B to look at this scenario. All right, and G of A, okay, G of A, okay, that's the same as G of x, okay, A's in the x position, remember. G of A is also going to equal B. So because any random point that we choose here, like A and B, we can choose M and N, whatever, we could choose an actual point if we knew what the equations are, but this is just showing that f of A, this is like f of x equals y, but we're using f of A equals B and G of A equals B, then that shows us that because these are equal to the same thing, these also have to be equal. So that shows that f of A equals f of B, or sorry, G of A. My brain's getting ahead of me here. All right, so because this is equal to this and this is equal to this, because these are equal to the same thing, B, that means these have to be equal, because I could substitute this into this equation. So f of A equals G of A, which is essentially the same thing as what this is saying right here. F of x equals G of x. Remember, I just replaced my x and y with A's and B's. All right, so hopefully that makes sense. All right, different words, same question. Which is different? Find both answers. All right, so this says, what is the solution of x plus 1 equals 2x minus 1? When are the values of x plus 1 and 2x minus 2 equal? At what point do the graphs of this and this intersect? Okay, so one thing I noticed is that this is looking for a point, which would be both an x and a y value. This is a solution, which would be just the x value. All right, so that's one difference I already see. What is the x value of the intersection point of the graph of this and this? So again, this is written in another way. We know that these two are the same. So which one is different? So this one is definitely different. I would say this one for sure is different. And then what are the values of x plus 1? All right, and this one is asking a different question as well. So when it says find both answers, okay, these two are asking the same question. These are asking something different. Okay, let's look at example 2, solving absolute value equations by graphing. Solve absolute value of x plus 1 equals the absolute value of 2x minus 4 by graphing. Check your solutions. All right, so this is still set up as f of x equals g of x. So we're looking for the x value that makes this equation true. Now, it's absolute value. Let's go back to our calculator. All right, let's go ahead and clear out what we had before. All right, so I'm going to go in. I want to graph. Remember, we got to have two equations. So we're going to have y equals the absolute value of x plus 1. Y equals the absolute value of 2x minus 4. All right, so to graph an absolute value, go to math. Come over to number, so you're going to arrow over to number, and it says ABS. So ABS is absolute value. So we got x plus 1. Then you're going to arrow out to get outside the absolute value. You want to make sure that's all inside the absolute value like this. All right, we're going to come down. We're going to do ABS again. So we got to go to math, number, absolute value again, 2x minus 4. Again, arrow, make sure you get out of the absolute value, and now I'm going to hit graph. Remember, we're looking for the intersection point, so the x value of the intersection point will be our solution. So here we're going to have a solution here, and we're going to have a solution here. So we're going to actually have two x values that will make this equation true. So let's look at them one at a time. So we're going to go to second trace. And we're going to find intersection again. All right, so we can hit enter because we are to the left. I'm going to try to find this point right here first. We're going to arrow over. I'm going to hit enter again. And it says the intersection is at x equals 1, y equals 2. Remember, we just need the x values. So let's do x equals 1. All right, again, we've seen that there are two intersection points. So now we're going to look for this one. All right, if we can count over 1, 2, 3, 4, 5. It looks like about x equals 5, but let's do it the correct way. Second trace. Let's go to intersection. Okay, this time I'm going to arrow a little bit closer to the point we're looking for. We're looking for this intersection point here, so let's hit enter. And I'm going to arrow up past the intersection point, hit enter again. And this one says the intersection is at x equals 5. All right, so again, we can check that using the table of values. And you can see that x equals 1 has the same y, and x equals 5 also has the same y. So this one does have two solutions and we have checked them.